Okay, guys, we're now going to present to you the law of cosines. The law of cosines, okay? And so let's start with that now, okay? Uh, and so it gets a little bit more involved in algebra. It gets a little bit more involved in algebra. Uh, I'm not going to go through all this, okay? It's there for you if you want to review it, perhaps in algebra next year. It'll be very important for you to go through all the steps, generating the process to come up with the law of cosines. As you can see, it's built on the distance formula, okay? And here is, okay, the end results of what's going to be producing for us, okay, the law of cosines. Now, the law of cosines is, okay, going to involve one of three formulas, but they're all very much similar, okay? So, and you can see it's kind of related to the Pythagoras because it has this a squared equals b squared plus c squared component in it, okay? So let's take a look. Here's how it sets up, okay? Again, as with law of sines, okay, we designate side A being opposite angle A, side B being opposite angle B, and likewise side C being opposite of angle C. There are the three, here are the three formulas, all right? And I don't mind giving them to you, but you got to know which one to use, okay? So you can see the variation in the formulas depend upon, okay, whether you have the angle A and the side opposite of it. So you have to have two sides, okay, and an angle, and be looking for an angle or a side, the opposite of which you have, okay? So we'll see this with some examples. Here is the other formulation, okay? So the only difference here is, okay, how the A, B, and C appear, all right? Just remember, A is equal to B squared plus C squared, okay? What's included here, A, okay, is not included over here except for the cosine of the angle. Okay, what's included here, B, is not included here. Okay, you see, B is on one side, A and C are on the other, except for the angle. And lastly, you should be able to surmise, okay, C squared, we don't include the side C squared, okay, or the side C. We include the angle opposite side C. Okay, so it's best to we look at some examples, okay? So first off, here's an example using the law of cosines, okay? Now, you should agree law of sines will not work for us because in order for law of sines to work, we need to have both the angle and the length of the side opposite it. We need to have an angle and the length of the side opposite it. We do not have that here. So therefore, okay, we're going to use the law of cosines. I wrote down but one formula because, okay, we're going to look for angle X. We're going to look for side X, which is going to be our A side, having the angle A. So the next part of the formula is just putting in everything, okay? Again, X is the side we're trying to find. That's going to go right here. The other two sides are B and C. They go into our formula appropriately. And we take the cosine of the angle opposite the side in question that we're trying to find. Okay? I'm going to do all the squaring. Okay? 52 squared, 2704, 16 squared, 256. Okay? And the cosine of 115 is a negative 0.42. Okay? I'm going to multiply all this out. First off, okay, the negative 2 times 52 times 16 times the negative 0.402. The negative times the negative gives me a positive. That collectively gives me 703. When I add those all together, I get x squared is 3,663. and therefore x is the square root of that, which is said to be 60.5. Okay? A lot of details, but as long as you get the formula right from the beginning, okay, and take your time, not trying to do too much at once, there's no reason why you shouldn't come out with it. I would suggest you take this problem at this point and try to work out and see that you end up with the same thing. Okay? Another problem, again, here, okay, law of sines is not going to work. Not going to work because we don't have an angle and a side opposite both known. We don't have any angles here. So we can't go through law of sines without any angles. In order for law of sines to work, we need to have a side and the angle opposite it. So again, we're going to start out with our generalized law of cosines formula. In this case, okay, as we see here, the first and the last term include the side and the opposite and the angle opposite it. The side over here by itself, in this case a squared, and the angle opposite it, a, over here. Got another interruption coming. I can't stop the video. We've got to keep going, okay? So I just put down the values. A is 24. B and C, doesn't matter which you call them necessarily. One is 37, one is 32, okay? And the angle opposite it is the angle in question. I do my squaring. I get those values, okay? I've got to ultimately solve for the angle x, all right? I combine these terms, the 1369 and 1024, to the other side, giving me a negative. The negative's going to cancel out. I'm going to get the negative 1817 divided by negative 2368 to give me this decimal value, 0.767. To find x, I got to go the inverse cosine, go to my calculator, the inverse, cosine to the negative first, the arc cosine as it's sometimes called, okay? We've done this all before, okay? And that gives me my angle, which is just short of 40 degrees, okay? Again, I would try this myself from the beginning, okay? And you can see right here, the opening side and the last thing involve the side and the opposite and its angle opposite it. The side and the angle opposite it at the front and at the end of it, okay? Hopefully that gives you some examples. You will have some to look at in class. I would try executing these for myself, like I said, and work along with viewing them on the PowerPoint that I've provided for you, okay? So that'll do it for now.